Hi, Brandon Lewis here of Embedded Computing Design, and I'm here today with Eliza Schaub, who is a director at Technologic Systems. How are you doing, Eliza?
I'm doing good.
Good.
Yeah.
So today we wanted to talk a little bit about some of the things that are going on because IoT is now finally making its way into the embedded and industrial spaces. People are trying to figure out how to implement this technology, but it appears that there's a little bit of a gap. Especially between the single board computers, that type of embedded technology that these vendors are used to, operators are used to working with, as compared with some of the networking appliances that you need to make a lot of this stuff happen. A lot of those end up being high end. What are your takes? What are you seeing going on there?
We are seeing that there's a gap. So you've got single board computers, they have networking ports and all the interfaces you need to do the IoT stuff. But eventually you got to get the data aggregated and back to the cloud. And it's that sort of aggregation piece that ends up being challenging. Because when you look at the network switch market, you tend to have a couple of little sort of the SOHO units that are the lower port counts that you probably need for your aggregation in most applications, but they're mostly commercial off-the-shelf products designed for consumers.
Okay.
And as soon as you start looking at something that's more robust and embedded and maybe the temperature range that you need for an embedded application, then you're starting to look at these really high-end Cisco switches that are also, which are great, they're a spectacular product, but they're very expensive, they're more part counts than you need, they're more features than you need, and you're paying for that too. And so that makes the whole installation more complicated and more expensive. So as we look at that in the market, we said, well, we know single board computers. We've done that for many, many years. And we know some about networking, and we're familiar with the electronics that all goes into networking, and can we push those together? So we're currently working on some new product lines where we take a single board computer and a bunch of more advanced features onto that, but we're also sticking with it a high-end industrial network switch in the small size. So it's a 5-port count switch. It's going to start bringing fiber, which is good if you've got a little bit longer distance between your aggregation nodes. But it's also a full-scale switch that can do your standard sort of L2 switching technology, but also start looking a little beyond that so that you can do more specialized time-aware things or more specialized deterministic kinds of Ethernet stuff, just depending on what software stacks you have, and even do some custom things with it too.
Very good. So it sounds like at Technologic, you're sort of moving up a little bit in terms of the integration and the capabilities of a lot of these platforms. Does that change anything for people that are using your product?
For the most part, no. It should look like a Technologic Systems board, but the total integration on it and the new features that'll come with some of this stuff will sort of take a natural evolution up from what we're doing today. So we take all of our familiar features. So one of the things that we do well in the market is bring the RS-45s and RS-232s and these things that the rest of the world likes to consider legacy, but embedded's really still using a lot of. We'll still have a full complement of that. We're looking at sort of taking the same analog game that we've been doing with 4 to 20 milliamps and some of the stuff you're familiar with us from that, and we're going to take that to the next step too. And bring heart to it, as well as some faster A to D conversion, so you can watch more sensitive signals and things like that. And we're going to take all of that and basically shove next to it an Ethernet switch, but with a CPU that knows how to handle an Ethernet switch.
Right.
So it's got all the network ports built into the CPU. There's a number of ports where if you don't want to switch, you want direct into the CPU, we've got that. But then we also will have options that have the network switch and the fiber options and things like that to sort of bolt all that together. And then we're doing all the software integration with Linux and bringing Linux's network platform and making sure it will talk to the hardware so that you can get the hardware advantages when they're there and they're useful, but it all from the top end looks like it's Linux.
Yeah.
And you don't have to know anything besides Linux to get to that networking.
Wow, a lot of more and more integration. That's the name of the game these days.
Yeah.
What about mid-range, lower end? People there are still looking for those traditional requirements of industrial embedded. We want it cheaper, we want it smaller, but we still want more stuff.
Yeah.
So what's going on down there?
Well, and we see that too, and this has been one of our fun little engineering projects. So we're all working on this high-end hardcore stuff, and it's getting there, but it's a lot of new development that's hard and complicated, and we like to get sidetracked with little engineering projects. So we actually have our most favorite current little engineering project is going to turn into that smaller, still affordable, and more features into much more compact shape. So we're actually developing what we're going to call the TS70-100 product. And it's one of our single board computers. So traditionally, if you've seen single board computers from us recently, they're kind of about that in size, with an enclosure that goes around it, no display capable. So our challenge to that was to take all of that and shrink it into the size of this new display that we found. And you'll find this display on our new higher end products too, so that you have simple user interface. But how do we take and smush everything into the size that is no bigger than that display? Of course, as we've wanted to pack features in, it kind of grew this way just a little bit, but not much. It's still going to be thinner in profile than our existing enclosured products. So we did get the smaller this way. We're definitely much smaller in the other two directions as well. But this has almost all the same features as one of the full-size boards. And one of the ways we're accomplishing that is we've actually gone and found a new screw terminal connector. It is the same pitch this way. It is a little bit less pitch this way, which makes it so that we can pack more in. Almost the same amount of electrical isolation, things like that. So it can go into nearly all the same applications it could before. We're putting in relays and stuff like that. So it's still a very robust interface, but we can get all the stuff that was otherwise taking 4 or 5 inches down into this new compact sort of package. So, and this one we're keeping an eye on networking and stuff too. So we'll still have 2 Ethernet ports. These are only 10-100. They're not going up to the gigabit. But and there'll be options in this eventually that'll do some of the more wireless interfaces and things too. So this will sort of span that low end and compact, and give you a new screen too.
Very good. When can people expect to see solutions like this out from Technologic?
This particular one, we just got the prototypes in-house. They haven't actually quite been turned on yet, but I expect that we'll be able to ship to a couple of customers, start getting people sort of playing with it and making sure it's worked out and robust here in the next probably 2 to 3 months. But then, we'll get into our engineering sampling quickly after that. So that's
very good.
Yeah.
Well, the networking and some of the compute and everything that traditional SBC would deliver is on its way into the industrial IoT, I'd say.
Yeah, we're going to get there.
Great. That was Eliza Schaub, Director of Technologic Systems. I'm Brandon Lewis of Embedded Computing Design. Thanks for watching.